Hi everybody, my name is Sherry Sassmannshausen and I'm going to present our paper Research and Practice Recommendations for Mixed Reality Design, Different Perspectives from the Community. Together with my colleagues Veronika Kraus, Florian Jasche, Thomas Ludwig and Alexander Boden, we conducted a literature study to investigate the current situation regarding design recommendations for mixed reality. When it comes to the creation of new systems, design guidelines play a crucial role. Using design guidelines can increase the chance to create a usable application even if a designer is inexperienced. They can also speed up the design process because designers can base their design decision on approved concepts. Design guidelines also support users in appropriating new applications if designers use the same convention across applications. Creating AR apps can be difficult even for professional designers. From our perspective, missing established design guidelines is one important reason. Well-known guidelines for 2D interfaces can only partly apply to AR applications, because AR have fundamental differences in presenting content and interacting with it. Guidelines for AR are currently very scattered, and designers often don't know where to find them. Also, the development of guidelines need time and effort to collect experience about which design works best. This time has not fully passed for AR, and with our study we want to investigate the current state of the art regarding design guidelines for mixed reality. In 2017, Ensley et al. Evaluated several papers about AR design and related fields, and classified them into 9 heuristics, here on the right side. In 2019, Wee et al. Extended their work by creating 11 design guidelines for XR applications with a focus on head-mounted displays. Both sets bear a likeness to each other and to well-known guidelines or heuristics, such as Nielsen's 10 usability heuristics for non-spatial interfaces. However, Ensley and Wee provide additional guidelines for AR that target the three-dimensionality of the medium and a more profound connection of virtuality and reality. So we conducted an iterative literature review to explore existing design recommendations. We therefore used the Scopus database with the following key search terms: augmented reality or AR, and design guidelines or design principles or heuristics. Without restricting the time period, we received 519 published papers between 2000 and 2020. After removing irrelevant papers, 89 scientific papers were left for our full-text analysis. From these papers, we extracted statements that can guide the design of an MR application, such as design principles, guidelines, heuristics, or general design recommendations. In sum, we received 374 statements. To complement our literature review, we considered design recommendations of MR-related companies. We have reviewed websites and documents of the 6 market-leading companies such as Apple, Google, IBM, Magic Leap, Microsoft, and Spark AR to analyze their design recommendations. And this document analysis resulted in 501 practitioner design recommendations. So we collected all statements on a virtual whiteboard in Mural and created an affinity diagram for each of the scientific design recommendations and the practitioner design recommendations. To create our clusters, we sorted the statements according to their similarity in content and finally arranged them under respective umbrella topics. With this approach, we identified common topics regarding design recommendations in MR research. When analyzing both datasets, we found that the topics are similar or have at least equivalence. Also, the clusters are not mutually exclusive, as can be seen in the picture. We will detail the similarities of addressed topics later. So we analyzed our data clusters in 4 dimensions. Regarding the unique design challenges, we found that it is popular in MR research to apply the design heuristics from Nielsen. Since these heuristics originate from non-spatial user interfaces, this results in rather generic design recommendations due to their lack in focus on MR specifics. When investigating the abstraction level, we saw that SDR are both device and ecosystem agnostic. We assume, based on our observations, that SDRs are, in general, device agnostic and explorative regarding applied technologies or mixed hardware approaches, whereas PDRs are device and ecosystem specific and focus on establishing standards. Regarding level of detail and abstraction of content, our analysis reveals the amount of information given with a design recommendation and the type of their abstraction as the main differences between SDRs and PDRs. SDRs tend to be of high abstraction regarding intended use and effect and give few explanations. At the same time, that level of abstraction leaves room for interpretation and experimental approaches. In contrast, PDRs are formulated from a developer's or user's perspective, abstracted from the application context, and provide examples of intended use and effect. While they usually do not restrict experimentation, they emphasize good practices. Finally, in comparison, SDRs and PDRs share similar concepts and topics on a divergent level of detail. SDRs provide a horizontal, framework-like coverage of topics, including experimental areas like tangible AR. PDRs focus on horizontal and vertical topic coverage to ensure applicability with a greater level of detail. As reported in recent work, MR design guidelines are perceived as being irrelevant. In this regard, we identified 3 factors that we introduce briefly. The terms design principles, guidelines, and heuristics are regularly used as synonyms, which leads to search results of varying abstraction levels with different purposes. We think that resolving ambiguous wording requires specifying the target group and the application context. Design recommendations fail to state their intended use, goals, and target group. While scientific recommendations aim for divergence with experimentations, practitioner recommendations provide greater detail for guiding application and aim for convergence. We think that explicitly stating the target group and the intended use helps to decide if a design recommendation can serve one's needs. And finally, the medium of publication denotes who perceives design recommendations as being relevant. As we know from literature, practitioners rarely consider scientific databases. Consequently, recommendations for scientific purposes are well placed on scientific platforms, whereas recommendations for practitioners are a good fit for respective platforms like Medium, YouTube, or Stack Overflow. Based on our study, we want to emphasize 6 implications for defining good practices. First, investigate, validate, and adapt existing design recommendations. Focus on the context of intended use and effect for spatial system design, as well as the recommendation's impact on design and user appropriation. The key to provide relevant recommendation is their grounding and validation in well-executed user studies with a diverse pool of datasets. So, long-term user studies should be preferred to minimize bias. Second, build recommendations on reliable and transparent data. Share experiments and practices. These practices can contain design decisions, patterns, or good practices. Third, recommendations for research need to foster experimentation and strive for generating knowledge by aiming for divergence. An explorative approach enables researchers to identify several potential solutions, to experience conceptual failures and working solutions, and generate knowledge about a design space's specific challenge and rules. Design recommendations for exploration aim for generalization and abstraction from context, domain, and user intent. Fourth, recommendations for practice need to guide the development of usable systems and aim for convergence. This is ideally supported by detailed explanations and examples showing the effect of use. Fifth, be clear about intended use and effect, user groups, and wording. Due to the ambiguous use of design terms, communicating the intended use and effect of recommendations is difficult, solely based on wording. The recommendations need to be formulated accordingly to fit the needs of the target group. We suggest including details about the intended use and context. And last, aim for a clear distinction of design recommendations and their purpose in research and practice. When working towards more distinct definitions, potential factors are, first, intended use and effect, like divergence and convergence, and second, level of abstraction regarding domains, devices, and user intent. With this, we want to conclude our presentation. Please read our paper for more information or contact us in case you have further questions. Thank you.